Hello friends, today we are going to discuss about jet streams. What do you mean by jet streams? A jet stream is a fast-moving, narrow band of strong winds. This is a climatological phenomena that can be seen in the upper atmosphere at an altitude of 30,000 to 40,000 feet. That means 9 to 12 kilometers. There is an interesting history behind the discovery of these jet streams. The discovery of these jet streams is generally attributed to Japanese meteorologist Wasaburo Oishi, early 20th century. He noticed the unusually fast winds encountered by Japanese fighter winds during World War II. However, it was not until the 1940s that scientists began to study these high-altitude winds in more detail. Then, 1944, the United States Army Air Forces sent a team of meteorologists led by American scientist Harry Vellner to study the jet stream using data from weather balloons and aircraft. Vellner and his team were able to measure the speed and direction of the winds in the upper atmosphere and map the location of the jet stream. What are the factors that influencing jet streams? First one is temperature gradient. That means the differences between two air masses. Jet streams are formed due to the temperature contrasts between warm and cold air masses. We know that in the equator region there is a warm air mass and in the pole regions there is cold air mass. So these differences can influence temperature gradient is a factor that can influence the jet streams. It can strengthen the intensity of jet streams. Second one is Coriolis effect. What do you mean by Coriolis effect? The force or the effect that produced by Earth rotation. The Coriolis effect that caused by the Earth rotation will deflect the moving air mass. In the northern hemisphere, it reflected direction to rightward, and in the southern hemisphere, it to left side. So these Coriolis effect plays a major role in the formation and direction of jet streams. Then these Coriolis effect leading the development of large-scale atmospheric waves. These waves are called Rossby wave. Actually, the Rossby waves are one of the major factor of Coriolis for that influencing jet streams. These waves contribute to the formation of jet streams. Next one is pressure system. Differences in atmospheric pressure also can influence the strength and position of jet stream. Somewhere there is a low pressure, somewhere there is a high pressure. These pressure gradient differences in pressure can also alter the intensity and location of the jet stream. The fourth major factor is seasonal variation. The jet stream position and strength vary with the season. During the winter season, the temperature differences between polar and subpolar regions are more pronounced. Okay, jet streams tend to be stronger and more active during winter season. But in the case of summer season, what will happen? Yeah, when temperature contrasts are less significant, jet streams are often weak and less defined. Next one is land and ocean features. The distribution of land and ocean features can also influence jet streams. That means the presence of mountains, coastlines, and other land or ocean features can also have impact the flow of jet streams. These features can cause the jet streams to meander or split, resulting in changes to its path and intensity. Then the next important factor that influencing jet stream is global climate patterns. Large-scale climate patterns, that means El Nino, La Nino effects, these all can influence the behavior of jet streams. These climate phenomena can alter temperature and pressure patterns in the tropics, which in turn can affect the position and strength of the jet streams. So how these jet streams are formed? Here is the first stage of jet stream. Here in our Earth, it is the imaginary line. That means equatorial low pressure belt. Right, it is the equatorial low pressure belt. Then here it is subtropical high pressure belt. And here is subpolar low pressure belt in the northern hemisphere. Right. So here the first stage of occurrence or formation of jet streams in the subpolar low pressure belt. That means here the subpolar, in this picture we can see the subpolar low pressure belt. The cold air mass come from where? From the poles, right? So from the pole, here is pole. From the pole, cold air mass will come, and in the subtropics warm air mass will come. When these two air masses come together, but it don't mix up. Why? Due to the great thermal construct and differences in the physical properties. That means it has two different physical properties. One is cold, and first one is cold and second one is warm. So due to these differences in thermal contact and differences in physical properties, it does not, or it did not mix up. So a zone of the stationary situation is created between these two air masses. There is a stationary situation, okay, and it is mid-latitude region. So what will happen in the second phase? The stationary situation is transformed into auxiliary wave, right? Once it is a stationary situation when there is no disturbance, now it changed, it transformed into auxiliary wave. Okay, these auxiliary waves are called Rossby waves. Okay, so what do you mean by Rossby waves? Actually, the Rossby waves are large scale waves in the flow of atmosphere that occurred in the mid latitude, that is subpolar regions of northern hemisphere and southern hemisphere. Here, I will explain how these Rossby waves are occurring. We know that it is mid-latitude region. Here, Rossby waves are actually created by interaction of Coriolis force and also temperature gradient. Okay, we know that Coriolis force are caused by the rotation of the Earth. Okay, then temperature gradient is differences in the temperature. Here the mid-latitude, here is polar region and here is subtropical region, right? Then in subtropical region, we know that the warm air, and the polar region here is cold air mass. Okay. So this is pressure gradient, two different temperature. That is differences in the differences of two temperature. Physical properties of temperature is called temperature gradient simply. Okay. So the interaction of Coriolis force and the temperature gradient. Then when there is a pressure gradient between two air masses, it creates a pressure gradient. Okay, we know that the temperature gradient leads to the changes in pressure gradient also. We know that the temperature increases, at that time pressure will decreases. So in the warm region, it will be low pressure, right? Because the temperature is high there. But in the case of cold air mass, here a high pressure will occur. So it creates a pressure gradient that causes the air to move from high pressure to low pressure region. We know that the wind move from high pressure to low pressure region. So whenever this movement will happen, we know that the Coriolis force deflect the moving air to the right in the northern hemisphere. Okay, left in the southern hemisphere. We already discussed about it. So this deflection causes the air to curve and create meandering. Okay, so this deflection of Coriolis force will leads to this meandering effect. That is, from stationary situation transformed into a meandering situation, okay, or a auxiliary wave-like pattern in the atmospheric flow. So these meanders can grow and amplify eventually forming large Rossby waves that can span thousands of kilometers. Okay, can span into thousands of kilometers. It can span into thousands of kilometers. Okay, in the atmosphere. These waves can have a significant impact on weather patterns and can influence the position, strength, and orientation of jet streams. In the third phase, here the cold and warm air further sees each other territory. Okay, we know that each other has their own territory. Now it sees each other territory. Okay, that means cold air mass sees the territory of warm air and the warm air mass sees the territory of cold air mass. Okay, when both cold air and warm air further sees each other boundary, there is a waves further meanderings occurred. So the jet stream development attained maturity. So it is a matured period. Okay, the cold air mass sees the area territory of warm air and warm air mass invaded the territory of cold air mass. There a jet stream developed. Okay, there is a jet stream developed and it is in a mature period. Okay, it is in a mature period. It is the final and fourth stage of formation of jet streams. Here the cold air mass moves into warm air. Okay, we can see the cold air mass was here, but now it moves the territory and invaded the warm air mass, and also warm air mass moves into cold air mass. So high pressure occurred here. Here there is low pressure. Okay. Then finally a stationary front situation is re-attained. Again it back to the same situation of first stage, a stationary front situated. It is a cyclic process. It will again and again it will happen. Okay. And finally, thanks for watching my video. There will be a second part for jet streams. It is a big topic, and wait for the second part. Thank you.